I'll start recording then. All right. So what we are going to be working on today is we are going to be working through our next project, which is the problem-solving plastics. Okay. Um, and so in this project, and I will share my screen here. That way you guys can follow along with me. Okay. So what is this project? So again, I'm going to walk you guys through this a little bit more than I would normally walk you through it, just because I can't be there with you guys every day to help you out. So how do we use, or how do the materials we produce impact society, and how can we use engineering design to minimize human impacts on the environment? So what we're kind of be looking at is, how does manufactured plastics and manufactured materials like plastic impact both society and the environment, and then how can we take these things that we've made, and things like plastic, which are a huge innovation but are really detrimental to the environment, and how can we work towards trying to negate those to make them a little bit better for our environment. And so in this project, synthetic plastics are a recent and powerful human innovation. As a result, plastics are everywhere, for better and for worse. In this project, you'll develop and share engineering solution to reduce the impact of plastics on the environment. Okay, and that's why I wanted us to get through the natural resources one. I thought it would be helpful for you guys to get this done. All right, and so let's kind of look over checkpoint one. Okay. And I guess if you guys want, I can explain kind of what's going on in checkpoint two as well. That way, if you finish up checkpoint one, you can work through this. But anyway, so you're essentially in checkpoint one, you're just going to be making a pros and cons of plastics. So let's get that opened. Check and make sure. Nope. Okay. All right. So the pros and cons of plastics. In this checkpoint, you will develop your understanding of a social group of materials called plastics. You'll describe what plastics are and explain the positive and negative impacts of their use. These explanations will help you decide the problem, or help you decide on the plastics problem you will try and solve. They will provide background information for your final product. So a well-justified explanation should include a claim about how plastics impact society, evidence to support that claim, and then reasoning that connects the evidence to the claim. Okay, so you're going to need to come up with a claim. You know, plastics are good because they don't really break down, so they're really hardy. Okay, and then what evidence do you have to support that? This study that shows that non-biodegradable plastics just don't break down is good, because then we can essentially keep these things for a lot longer and then connect that back. Okay, so the first thing you're going to have to do is describe what plastics are and how they're made. Okay, that'll take you a little bit of researching. How do plastics impact society? Consider both positive and negative impacts. Okay, so I want you to basically make a positive list and a negative list. Okay, and let's say I probably want at least 5 things for each one. Okay, all right, let's go 3 for each one. But if you did 5, that would probably be better in the long run. But 3 minimum for both positives and negatives. And then kind of explain, don't just say it's a positive, say it's a positive and then say why that is a positive. Okay, and then explain one of plastic properties is that it does not easily decompose. Explain why this is a benefit and a problem. Okay, again, benefit, doesn't break down, can last a long time, we can use it a lot longer. Problem, people have a pretty good tendency to, number one, we package everything in plastic. And number 2, people throw this plastic out. When you're using non-biodegradable plastics, they're just going to stay around forever. Okay, plastics do not break down. All right. And so that's pretty much just this whole thing. Relatively simple. You're just kind of, what are plastics? How do you make plastics? What are some pros and cons of plastics, and why are those pros and cons? Okay. And again, I want you to say why, because just like down here, it not decomposing is both a pro and a con. So that you can have things that are on both lists, but you need to explain why they're on both lists. Okay. Does anybody have any questions so far? I will take the deafening silence as a no. There are no questions. Okay. And so, again, let me show you. Where is it? So this is, you're going to be graded on this rubric, okay? So a 3 is kind of what we're shooting for. Constructs an explanation about observed relationships to describe the phenomenon based on empirical evidence, okay? So the big thing between 3 and a 4 is a 4 is talking about a disciplinary idea. So a disciplinary means it's very directly like, you understand that plastic doesn't break down because of what it's made out of, and those polymers are meant to stay together and not break down. Whereas an empirical evidence is just something that you have noticed, okay? So a 3 would be like, oh, I just noticed that plastics don't break down, plastics are hardy. You know, I see that there is a lot of plastic in the ocean, especially like the Pacific garbage patch. That would be like a 3. A 4 would be talking about the polymers and kind of what they're made of and getting a little bit more scientific with it. And then a 5, which is like 100% for you guys, just showing you this. When relevant, identifies the limitations of evidence, okay? A lot of you guys, this is why you guys sometimes miss out on 5s, is when we look at this, there's a lot of identifying limitations, okay? So kind of just be like, yeah, this is, you know, I can explain to you what polymers are, but the evidence that we have is not, or that I have is not good enough to say whether this is a completely good thing or a completely bad thing. So just kind of talk about that a little bit. All right. And so this one right here, the science of plastics, this is a little resource card. Again, I'm pretty sure all of this, you can pretty much use these things to answer your questions in checkpoint 1. Okay. Again, so this is what a plastic is, pretty much right here. And I don't want you to just copy and paste, okay, what a plastic is. I want you to go through, read it, and then write it in a way that makes sense to you, okay? If this says, if your thing says exactly what this says, then I'm going to send it back and say, write this in your own words, okay? But yeah, so plastics are a group of material, either synthetic or naturally occurring, pretty much almost always synthetic, that may be shaped when soft and then hardened to retain their given shape. Okay, that's another really good thing about plastics. They're really easy to heat up, shape, and then they harden. Okay, plastics are polymers. A polymer is a substance made of many repeating units. A polymer can be thought of as a chain where each link is a mer. So a monomer is a single one. Poly means many. Okay, these can be up to like 1,000 links. All right. Again, there's a few naturally occurring ones, like cellulose and latex, but for the most part, they are synthetic. And synthetic is something that is made in the lab. They're not naturally occurring. All right. How are plastic made? The characteristics. So this really right here, you have a lot of the information you need to answer that very first question. Okay. You have a positive impacts of plastic. All right. All of these are some good things. Okay. Same thing with the negative one. There are the negative impacts of plastic. Okay, all of those. And again, if I just see copy and pasted this into your checkpoint, that will not be good. You can use this, but just make sure you put it into Kendra words or Katie words or Joseph words. Don't make it Summit words, make it your own. And I understand that some of these are explained pretty simply. I mean, it's made for, kids to read, but just make it so that you're not just copy and pasting. You can paraphrase it, put it into your own words. We would do a structured academic controversy, so where you guys are kind of looking at both sides if we were in class, but due to the fact that we're not, that makes this a lot harder. And then there's a video that I think would be pretty good for you guys to watch. This just talks about the life cycle of plastic. It's not super long. It's only 4 minutes, okay? So I would go through and watch this. This will help you to, again, answer all of those questions in checkpoint 1. Really, if you sit down, read through this stuff, and bust it out, I don't think checkpoint 1 should take you guys a whole lot longer than half an hour to an hour at the most. If we were in class, this is something I would expect you guys to do in roughly a period. Maybe it would bleed over into the second period a little bit, but I think you guys are definitely capable of doing that, okay? And so before we move on to checkpoint 2, I want to see, does anybody have any questions here? Nope. Is anybody even there?
I'm here.
My man Joseph. Perfect. Okay. All right. And Anjali is here. Good. I understand that this is a little less engaging than we would normally be in class, but I do need a little bit of back and forth at least to understand that you guys are here. Perfect. So if nobody has any questions about checkpoint 1, since we still have quite a bit of time, I'll just go ahead and explain checkpoint 2. That way, if you guys finish checkpoint 1 and you want to move on, you definitely can. Checkpoint 1 is the only thing that is due on Tuesday, but obviously, the more you work ahead, the better off you'll be. So I'll go through checkpoint 2 right now with you guys as well. Okay. And so checkpoint 2, this is defining your design problem. So you're going to gather and evaluate sources on a specific impact of plastic on the environment and define an engineering design problem to lessen that impact, okay? And so the 2 things that you guys are going to be graded on is defining a design problem, okay? So the definition of a simple design problem is complete. It includes several criteria and practical constraints, okay? So materials, time, or cost. Okay, definition of the problem or design statement is complete, identifies several relevant criteria. So the big difference between a 3 and a 4 is you can come up with a pretty simple one versus a more complex problem, okay? And obviously, if you do a simple one, plastics are not very biodegradable. So if we just make plastics with up to 60% biodegradable material, then we will be good, right? That'll be great. And then some things that are problematic are there are only so many materials and it will cost more, okay? The more complex you get with it, kind of leads you into that 4 range. And then if we look at a 5, including rationale. So when you're talking about your problem, the big difference between a 4 and a 5 here is that you are including why you think this is a problem and why you think that we should be fixing this problem. Okay, so really including a good why and how, that's going to be huge. Okay, and then instead of just identifying a couple of criterion constraints, you're addressing multiple. Okay, so the more criterion constraint you address, the better your grade is. So, okay, pretty much it's just 3 is a pretty simple idea, 5 is a much more complex idea. 3 has a couple of things like, oh, it'll cost too much. 5 is you're really addressing some of the elephants in the room, okay? Then if we go down and look at Selecting relevant sources, okay? Select sources that provide key evidence key evidence relevant to the research question. When relevant, sources vary in format. Number 4, select sources that provide credible information. Okay, so a lot of you guys do well and get 4s, okay? Because most of you have gotten to a point where you're finding relatively credible information. And while you guys are working on this, if you want to email me and say, I don't know if this website is credible, just shoot me the link, okay? So copy and paste the link into an email. I'll open it up and I'll say credible, not credible, okay? And do try and find things that vary in perspective or format, okay? So don't just find a million websites, all right? Try and find a website that says something, an article that says something, a scientific paper that says something, okay? And then like a 5, this is going to be when you're finding detailed, credible information relative to, so really we just move, the big thing is going to be a 3. It's got evidence, its credibility is kind of debatable, but it's a pretty basic website, and all you're doing is really finding websites. 4, you're going to find some articles, you're going to find some information that is good, it's credible, you've checked that with me or you've checked that somewhere else, and you do try and use a couple different places. And then a 5, this is where you're getting into that. These are some pretty, meaty papers that might be, I'm not telling you to go find something that is written for, a third-year graduate student in a chemistry polymer experiment, but I do, finding more detailed stuff, something that's going to push you in terms of trying to understand what the information means and trying to, 5 is kind of pushing yourself a little bit. All right. Does anybody have any questions about that? Okay. The only thing here that is, available is this criteria and constraints thing. And so this just explains, again, what a constraint is, what criteria is. So if you need to look at that, you can help you to figure that out. But then let's just go ahead and get in here and look at your checkpoint. Okay, and so the very first thing, what environmental impact of plastic will you focus on? So you should have come up with some of the impacts on society and all those things. And really, in your first checkpoint, you need to figure out one that you're really focused on, okay? So again, kind of an easier one would just be like, plastics do not decompose. Some other things would be like in the ocean, plastics don't decompose, but they break into small pieces of plastic, and we find in fish, there's a lot of microplastics, little small ones, okay? Why is this an interesting topic to you? Well, because I like fishing. I also know that there is a decrease in sea life. And if we were to take away some of these plastics, that might help to boost some of the sea life coming back, okay? So once we get that figured out, this is down here. You're going to post your source with a link, so you'll just copy and paste the link into here. Explain why it's a good source. This should be not just one word, not just one sentence. This should probably be, I don't want it to be like a million sentence, probably go like three sentences would be good, and then take some good notes on it, okay? Probably 3 to 5 notes per source at least, okay? Again, the more notes you have, the easier things will be in the long run, all right? And I do want you guys to get 3 sources. So then defining your engineering problem, all right? And so this is pretty simply, this is the checkpoint right here, or this is the thing you'll be graded on where you're selecting sources. And down here, this will be defining your design problem. Ask, how might we question? So to define the design problem, okay? There's a video about how might we. So this is going to be like, how might we remove plastics from the ocean, or how might we take plastics and make them so that within a 3-year span, they begin to break down a lot more easily. Okay, then again, criteria, constraints, okay? So what must your thing do? That's criteria, okay? And then constraints, what limitations do you guys have, all right? And again, the more criteria, the more constraints, and the more complex they are, the better your grade will be, all right? So, does anybody have any questions? Because if nobody has any questions, I will go ahead and end this meeting, because I mean that's really just those first 2 checkpoints. You need to get checkpoint 1 done by Tuesday the 13th, 14th, Tuesday the 14th. All right, and then if you finish that, I would suggest just moving on and start working on checkpoint 2. Okay. If you guys have any questions, please email me. I'll get back to you as soon as I can. Joe, make sure you get your last project done. And you still also need to take that natural resources content assessment at some point. Okay. So if there's no questions, I'll let you guys log off, and I will